Hello, hello everyone. Today is November 1st, 2024. It is 9:59 p.m. From my YouTube channel, scroll down Topology, Differential Geometry, Tensor Calculus. Click this playlist. From this playlist, scroll down, select episode 020. From this episode, show more, download current video source code. Show in folder, unzip it. Rename 021. Cut, paste it in your working directory. In this folder, images. I will copy and paste this image file. Now open up Visual Studio Code. Topology 1, here, 021, open up exe01, Ctrl V, Ctrl Home. I will delete, then paste, Ctrl Home. To follow my current session, you need up-to-date CPP library extension. If my source code does not build on your machine, then you have to download up-to-date C++ library extensions. I will fold it up. Then include cpg library.hpp. We need this header file. I will close folder, then open again. The squiggle goes away. I will drag and drop this PDF book. Thomas's Calculus, Early Transcendental. In this book, page 920. Hit enter. Then you can find exercise 15.6. In my current session, we will find the centroid. This problem in gory detail. Copy this text, Ctrl N. Here, paste. It should be fixed like this. This is from Thomas's Calculus. Here, for the problem 3, I will copy this, paste it here, finding centroid 1. CPG display function name. Copy this function name, paste it here. I will disable this. Now I will read the problem. Find a centroid. Find the centroid of the region in the first quadrant, bounded by the x-axis, the parabola y squared equals 2x, and the line x plus y equals 4. I have drawn an image. Problem 3, Ctrl B. It looks like this. So this curve y squared equals 2x, y squared equals 2x. Then x plus y equals 4. So this graph x plus y equals 4. Because this problem is simple, we can find the crossing point. But in real application, finding the crossing point is by no means simple. We need enum underscore x underscore y semicolon or x y OPR bar 2. We define y squared equals 2x. So we define like this. Auto f y times y minus 2 times x. Then we define x plus y equals 4. So auto g x plus y minus 4. We defined two functions. This function and this function obviously not linear. Auto points, it is plural. Cine solve system of non-linear equations. Semicolon. Tuple we pass f and g. Okay, the first argument, then std array, std fair. This is for x boundary. So we are solving in the first quadrant. Lower boundary for x is 0, 0. Upper boundary, I would just set 5.0. Then std fair. Now we set 0, 0, 0. I would just set 5.0. This is y boundary. Then comma std array, we will bisect into 2 by 2 segments. If it fails, then we can try again. std cout points, then points nl. I made type here. With this, open up any compiler. C 021 moments of inertia. Clang std C++20. Our source code file name is exe15601.cpp. exe15601.cpp ltb12 or c.exe. Hit enter. clsc. Wow, we solved 2, 2. So the crossing point is 2, 2. Why we have to solve our problem like this? Because in real application, finding the crossing point is extremely difficult. In real physical problem, finding the crossing point is extremely difficult in some case. I will briefly explain why we need to solve system of nonlinear equations. We, in some case, cannot find crossing points of the real physical world problems because not infrequently our functions are specified implicitly. In such case, finding the crossing points become extremely complicated. So we need solve system of nonlinear equations algorithm. I designed my C++ library extensions to solve real-world problems. Here, auto x cross y cross equals points front. So x cross y cross represent the crossing points. Here I will summarize. X cross Y cross represent the crossing point. I will arrange like this. Now, all M N Cine integral semicolon the mass of the enclosed area 1.0 per unit density. We will define y limit. Y limit runs from 0 to 2. So 0.0, 2.0. This is for y limits. Now tuple, this is for x limits. We draw horizontal line. Then the lower limit is y squared equals 2x. So x is half of y squared. Y times y over 2. This is lower limit. Upper limit is 4 minus y. This is wrong. This is wrong. See, y takes 2 parameters. Here, y takes 2 parameters. X and y takes 2 values. So, the following is wrong. Instead, we should define like this, yy, and all yy equals bar 1. Now we define their differential order. We defined y limits first. So underscore y, then we defined x limit. So underscore x. We defined all. With this, we build once again. It built successfully. Now, I would set overall density 1.0. Then, it is density. Copy this, paste it here. I will remove this comment. This represents integration order or differential dx dy order. This is first moment with respect to y-axis. Then my times x. X represents the distance from y-axis to the mass element. Copy, paste. Now, first moment with respect to x-axis. Y represent the distance from x-axis to the mass element. Here, auto centroid A array 64.0 over 35, 5.0 over 7. Answer from the textbook. Auto centroid N array my n over mn mx n over mn. If we want to, we can display mass. LCD C out M N equals M N N L. Now scroll down. LCD C out Centroid A Centroid A N L copy paste Centroid MN MN NL. So we found Centroid. With this we build again. Sorry, it should be MX. We build again. CLSC. The answer from the book. Our numerical solution matches exactly. Now scroll up. I will copy from here up to this point. Copy, paste. Scroll up. It should be 2. Now I will remove this comment. I will also remove like this. Then here I will remove all. Watch it very carefully. We will define integration based on x-axis. We bisect the region into 2. We bisect the region into 2 like this. Plus CNA integral we bisect density 0, x cross left region cut paste. This is right region. Say with respect to x cross. With respect to x cross. This is x limits. Now tuple we are specifying this region with respect to x-axis. The lower bound is 0, so lower bound. Upper bound is CNM SQRT 2x. This is wrong. We have to use XX. So auto XX bar 1. See, upper bound is square root 2x. So square root 2x. This is y limits. Then here we have to specify x limit first. So underscore x underscore y. Take note the order of the integration. Now right region with respect to x cross. X cross is 2. Okay. Density we specify x cross. X cross is 2. Upper bound is 4. So 4.0. This is x limits. Then tuple lower bound is still 0. Upper bound is y equals 4 minus x. So 4 minus xx. This is y limits. Dear underscore x underscore y. Now copy this, copy, we will paste. Then this is first moment with respect to y-axis. So we have to multiply x. Also here, multiply x. Now copy this, paste it here. Sorry, this is my, this is mx. We now multiply y. So everything is done. Copy the function name, copy, paste it here. We'll be using Intel compiler CD021 moments of inertia ICXCL QSDD C++20 don't miss EHSC MD OD, let's ignore OD. Then F no SQL OI.exe, hit enter. Sorry, exe 15601.cpp, hit enter. CLSI. So everything works exactly the same, but there is slight difference. Okay, there is a slight difference. Also slight difference. This is not slight difference. In this case, it matches exactly. In this case, there is slight difference because in this approach, we are using square root. Also, square root. Square root is not very accurate when the slope is less than 1. Now, scroll up from here, copy up to this point, copy, paste, scroll up, we will rename Centroid 3. Here, I will copy these links, Green's theorem, area formula, Green's theorem, first and second moment formulas. I will just make it shorter. Green theorems for area formula, area first and second moment formula. A while ago, I filmed this video, also this video. Control click in episode 93, Green Theorem 5, area and the centroid, first moment, vector calculus. I filmed this video 8 months ago. If you watch this video, you can learn these formulas or this video. In this episode 094, Green Theorem 6, Green Theorem for moment of inertia, I derived formulas in this book, page 991. In this page, Green's theorem in the plane, you can find some interesting formulas here. Areas as line integral, also area and the centroid, moments of inertia. I discussed these formulas in my previous episode, Green Theorem for moments of inertia. Now I will give you more explanation. I will copy this. Refer to 16.4 Green's Theorem in the Plane, page 991, from this book, Thomas's Calculus, 13th edition, with f given like this. In xy plane, area equals 1/2 line integral f dot dr cross k. I will give line break here. Say r equals dx. I will just copy this. dy plus dc k dr. This is area formula. This is a x bar. Then it becomes 1/3 times the x. Copy, paste. Now y bar. This should be y. I will indent. This is area and the centroid. Then moment of inertia. Copy this, paste. This is Ix. It should be 1/4 x square. This is Iy, 1/4 y square. Sorry, this is y, this is x. Don't get confused. I explained all these things in 2 of my previous videos. Approximately 8 months ago, we will apply these formulas. If you compare with the textbook, there is slight difference. Green's theorem area formula. This equation is exactly the same with this, because here we put this, then this, we get x dy minus y dx. In the same manner, it will be 1/3. Then we have to multiply one more x, then x here. So this equation is this, exactly the same. In the same manner, I copy this, paste it here. It should be 1/3. We multiply y to this equation, then xy y squared. Scroll down. Now here I copy the area formula here, then should be 4. Then we multiply x squared, then it becomes x cubed and the x squared. In the same manner, I copy this, paste. It should be 1/4. We multiply y squared, then it becomes y cubed. So this is this formula, exactly the same. Now we solve real problem. Here we will delete this. Also delete this. Also delete this. Scroll up. We start the mass of the enclosed area. Please watch very carefully. We define the boundary of this region. This is C1. C1 starts from 0 up to 4 along the x-axis. Then C2 from 4, 0 following along the line up to crossing point. Then C3 along this parabola. So overall C1 BCTR 3D line we define from 0.0 4.0 0.0. This is starting point. Copy, paste. This is end point. End point. I would say start point, end point, point. Okay. I will give a line break like this or like this. Now copy, paste. This is C2. C2 starts 4, 0. So 4, 0 to this point. This is X cross, Y cross. Copy, paste. This is C3 from crossing point to origin. Please remember, we have to consider the direction of vector. We cannot use this. Instead, we have to define vector. VCTR3D. This is vector. How can we define this curve? Y squared equals 2x. How can I define this curve? My point is how we are going to define this curve. Well, x equals a half y squared. So we let t, y equals t, then x becomes t times t over 2. X equals t square over 2. Okay? We haven't defined t yet. So, overall, t equals bar 1. In this case, this t runs from 2, 0. T runs from 2 to 0. In this case, the internal parameter t runs from 0 to 1. I say internal parameter. Copy, paste. Cut, paste it here. Here we define C1, C2, C3, the boundary curve of the enclosed region. Now here we apply this formula. Copy, paste. We define overall KF VCTR 3D 0.0, 0.0, 1.0. This is cross product. Then VCTR 3D X, Y, where we define this overall area cut, paste. C1 line integral. The integrand is kf. Then 0.0, 1.0. I would use like this. Then plus C2, then plus C3 line integral kf. In case of C3, t should run from 2 to 0. So 2.0, 0.0. Don't forget, we have to divide by 2. I will give a blank space here. Scroll up. Now we are applying these. Scroll down. I will paste it here. Then comment. Here we copy these. Paste it here. We now multiply x. So x, x, x. Don't miss. It should be 1/3. So 1/3. I will align. It is ax. Now copy this. Paste it here. This is ay. Now this should be y, y, y. I will align like this. Everything is ready. Now area. I will delete. It now should be ax area, ay area. We have to copy this function name, copy, paste it here. We'll be using Microsoft Compiler CD 021 4 months of Inertia CL SED C++ 20 EHSC EXE 15601.cpp fe m.exe. Hit enter. Wow, so many errors. We will rebuild. Scroll up 490. Parenthesis missing before curly brace. 490. Go 490. I missed comma. Also comma. With this CLS we build again. CLS M. Wow, beautiful, perfect. Everything looks perfect.